Hello friends. uh, Today we'll be discussing about the introduction to design of steel structures. Will be the part 2. As we had discussed with the part 1 initially. So I'll just give a brief introduction of the previous part which I had given. In the previous part, we had discussed about the properties of the steel, structural steel, stress strain curve, and the structural steel products, and the choice of the section. So these are the 5 points which I discussed mainly in the first video lecture of the part 1 of Introduction to Design of Steel Structures. So now coming to the this part 2, I have taken some few more topics which I'll be covering in this video lecture. They are listed here: types of steel structures, the structural members, the design philosophies, the limit state method, and the limit state method, which are the three methods, and the fifth one is the partial safety factors. So overall, with these two video lectures, will be covering almost the introduction part of the steel structures. Okay, so let's see the first one, that is the introduction to steel structures. As we know, steel structures are various different types of steel structures are available. So here I have first taken in order, like I have listed them, and first one will be the buildings. Okay, coming to the building, these include buildings include the buildings include the rigid, semi-rigid, or simple connected frames, load-bearing walls, and cable-stayed cantilevered structures. And also for multi-story buildings, several lateral bracing systems have been developed, like truss, staggered truss, and rigid central core, etc. And buildings are also like classified according to the residential, commercial, industrial, and depending upon that, depending upon the specification, we can choose the different type of structure, like depending upon the availability of the materials and depending upon the client's requirement. So we can choose the different type of structure, whether it is simple story or multi-story, with single bay or single bay, or multi single bay, or also many spans can be dealt with. Okay, so these are under the buildings, these are the some of the types which can be referred. And coming to the bridges, bridges are classified into the truss bridges, plate girder, arch bridge, cable stayed bridge, and suspension bridge. So these are the different types of bridges which are being referred to. And truss and plate girders are commonly used for the small to moderate span bridges, while cable stayed suspension bridges for the long spans. Okay, so these are the different types of bridges which are listed here. And the truss types also include the duct type and through type also. And the duct type is preferred if the clearance below the truss is not a critical factor. Okay, so these are the some of the bridges which I have just given a brief idea about. And next, coming to the towers, as we know, we use the transmission towers, lighting towers, and like many different types of towers which are being used. And those are all the steel sections, or the steel members which are being used. So various different types of towers are being listed here: power transmission tower, lighting tower, observation tower, telephone relay tower, and tower for radar and TV installation, windmill tower. So these are these are the different 5 6 types of towers which are being used for different types of specifications and depending upon the requirements and the need. So these are the towers. And coming to the like miscellaneous structures, or the other different types of steel structures: the storage tanks, silos, bunkers, domes, folded plates, chimneys, cooling towers, are the again some of the different types of structures which can be listed, which can be told like other types of structures or miscellaneous structures. Okay, so these were the different types of steel structures which we discussed. Okay, now coming to the structural members. Okay, structural members there are various different types of members according to the force transmitted have been discussed here. So the different types of structural members are the tension member, compression member, beams, torsion member, and the plate. Okay, so we'll discuss the tension members now. Okay, tension member is also called as ties member. Okay, okay, tension member. They are the members which are subjected to axial force, which try to elongate the member, and as I said, they are also called as tie members. And the form of tension member is also governed to a large extent by the type of the structure which is a part, and by the method of joining it to the adjacent member to the structure. And they occur as the components of the trusses, hangers, and the cables for the floors and the roofs in the bracing system as the tie rods. Okay, so and also axial loaded member carries the uniform stresses, and expected efficiency is 100%, but in practice the efficiency is not 100%. It is because of the effective area of the tension member is less than the gross area due to the presence of the bolt or the rivets, or and the shear lag effect. Okay, so due to this the efficiency is not proper or efficiency is not 100%. So coming to the this slide, here I have just shown some of the different types of tension members which can be used for the structure for the design of steel structures. Okay, this is the L shape or the angle we call, and this is the T shape, and this is the WS or M shape, and this is the pipe, and this is the double angle and double channel and built up plate and angle and double plane truss. Okay, so these are the tension members which can be inculcated into the steel structures. So second was the compression members. So compression, these members in a structure are subjected to loads that tend to decrease the length. Okay, as it is decrease the length, as you can see in this small figure, the compression is there, like the force is acting above it, and here it is a fixed, so that the member is being compressed, or the decrease in the length is there. So here it is, when it is subject to load, it tends to decrease the length. When a compression member is vertical in a building frame, it is termed as column columns or post or stanchions. Okay, so and if the column is required to resist a load acting concentric to the longitudinal axis, it is termed as the axially loaded column. Okay, and when the compression member is in horizontal effect or incline, it is called as strut. Okay, and strut may be concentrically loaded or loaded through one leg, it can be eccentrically loaded also. And the jib of the crane which carries the compression is called as the boom. Okay, and the state of instability is reached at a much at a reached at a load much below the crushing strength of the compression member. It is called buckling columns. Okay, now the next member is the beams. They are also called as the girders, and they are the flexural members. Here is just a simple beam with UDL has been shown, simply supported beam of length L, and the beams are primarily carrying bending stresses which are the largest at the extreme fibers. Most of the materials of the beam remain unstressed, and it is not fully utilized. This means that the beam which is adopted in this structure, it's remain unstressed, that the it means that the whole area or the whole stress of the beam is not being utilized. utilized in the structure. And the bending moment reduces towards the support, and if the beam section is uniform, even the extreme fibers carry a smaller stresses, and the strength if the beam is not fully utilized. So now coming to the next, torsion member. Machine shafts which are subjected to torque or turning movement are referred to as the torsion members, and the beams which are curved in plane are subjected to torsion. Here is a figure which is shown, and this is the here it is shown the torsional effect is shown, and torsion effect is also considered in the spandrel beams due to their interconnection with the cross beams. Okay, so these were the like different types of structural members which were discussed. And now coming to the design for philosophies, these are the main philosophies with regard to the structural design. They are the working stress method and the working stress method, ultimate strength design, and the limit state method. Okay, so one by one we'll be discussing about these philosophies, and the main philosophy which is being used nowadays is the limit state method. Okay, so we'll discuss about them in detail. So coming to the working stress method, as it is mentioned here, it is also called as the allowable stress design or the elastic design method also. Okay, and it is one of the oldest systematic analytical design method. And though IS 800 2007 insists for the limit state design, permits use of this method wherever limit state method cannot be conveniently adopted. This mean I mean to say that wherever the limit state method cannot be used, or where it cannot be convenient, the working stress method has to be used. Okay, and this method is basically assumes that the structural member behaves in a linear elastic manner, and adequate safety can be ensured, suitably restricting the stresses in the material due to the expected working loads. Okay, and to take care of the uncertainty in the design, the permissible stress is kept as a fraction of the yield stress, and the ratio of the yield stress to the working stress itself is known as the factor of safety. And here is the formula given for the permissible stress. Permissible stress is equal to yield stress by factor of safety. Okay, and the permissible stress or the allowable stress will be in the elastic range of the material, and it will be less than the yield stress, that is Fy. Thus in this method, working stress is less than or equal to permissible stress, and also yielding or buckling never occur at the working loads, as the working stress is less than or equal to permissible stress, and thus in working stress method, this yielding and buckling never occurs at the working load, and also deformations are evaluated at the working loads itself. Okay, and there are some of the limitations also, limitations also which can be which are due to this method, and we result the result due to this design method or this working stress method is the we get the uneconomical sections. So this is one of the major disadvantage, and also we have some of the few advantage, and this method is very simple, and it reasonably reliable, and as the working stresses are low and the serviceability requirements are satisfied automatically. So this is the working stress method which was being used, and also if it is used when the limit state method is not convenient. Okay, now the second method is the ultimate strength design. Okay, this method is also known as the plastic design or the ultimate load method, and this was based on the ultimate strength of the steel at the ultimate loads, and this was introduced as an alternative to the working stress method which we discussed earlier uh, in the IS 800 1962. Okay, and when this is applied to the steel structure, it is referred to as the plastic design method. Okay, with plastic design method, it is a special case. It is a special case of limit state design, wherein the limit state is attained when the members reach plastic strength MP and the structure is transformed into a mechanism. Plastic movement strength is a movement strength when all the fibers of the cross section of a member are at the yield stress Fy. Okay, and the safety measure in the design is introduced by an appropriate choice of the load factor, and the load factor is equal to ultimate load by working load. Generally load factor is assumed to be 1.7, and also it depends upon the it depends upon the working load. If dead load plus imposed load and the seismic load is used, then the load factor is 1.3. It is a minimum load factor which can be used, and if it is dead load plus imposed load, then 1.7 can be used. Okay, and if we see the disadvantages of the limit state method, this ultimate load method is the it does not guarantee the serviceability performance. To account for this, IS 800 1984 suggested limitations on the deflections. There were limitations of the deflections, which was mentioned in IS 800 1984. However, it doesn't guarantee the other serviceability requirements like the like instability and fatigue, etc. And finally, it was suggested more comprehensive method to take care of the design requirement from the strength and the serviceability criteria. And apart from this, there are also some of the advantages also. So redistribution of the internal forces is accounted in this method, which is also an important factor, and also varied selection of the load factors. As I said earlier, the load factors for the different types of loadings can also be selected. So this will also be an advantage for this method. Okay, so these were the two methods. Now the method which is being used nowadays, we'll be discussing, that is the limit state method. Limit state method, it is the comprehensive method. It is a comprehensive method which will take care of the both the strength and serviceability requirements, and this is mentioned in IS 800 2007, which is a recent one, and it suggests use of this method widely. Okay, and so what is the limit state? First, let's see what is limit state. Okay, the acceptable limit for the safety and the serviceability requirements before the failure occur is called as limit state. Okay, the acceptable limit for the safety and serviceability requirement before the failure occurs is limit state. Okay, and this again further it is classified into two limit states, that is the limit state of strength and serviceability. And also, while considering this, the designer has to ensure that he designs for the fit for their purpose, safe, economical, and durability of the structures. And also uncertainties also should be taken care about the loading, material strength, and the structural dimensions of the behavior of the structure. Okay, so now let's discuss the limit states of the limit states of strength and serviceability in detail. Okay, limit state of strength, this is associated with the failures under the action of the probable and most unfavorable conditions of the loads on the structures using appropriate partial safety factor which may endanger the safety line and the property. Okay, and this limit state of strength includes a few points to be considered in the design, and in the design, or which are the key points to be noted. Loss is equilibrium of whole part of the structure, and loss of stability, failure of the excessive deformation or fracture due to fatigue, and the brittle fracture. So these are the points which has to be included in the limit state of the design. And the attainment of one or more limit state may be regarded as the inability to sustain an increase in the load. Hence ultimate limit states conditions are to be avoided. Okay, And also these ultimate limit states are those catastrophic states which require a larger reliability in order to reduce the probability of its occurrence at the very low level. And now next is the limit state of serviceability. Limit state of serviceability. This is related to the satisfactory performance of the structure at the working load. These limit states deal with the discomfort to the occupancy or malfunction caused by the excessive vibration, deflection, corrosion, etc. Okay. So here I have listed the same, like which I told just now. The limit state of serviceability include the deformations and the deflections, and also the vibrations and the repairable damage or crack due to the fatigue, corrosion, and durability, and the fire. Okay, so this is the limit state of serviceability, and these are the points to be included. So now let's see the major, let's see the difference between the working stress method and the limit state method. Okay, the working stress method which was being used, and it is the old edition, we can see it is the IS 800 1984, which was used way back. And the recent method, the limit state method, is the based on the IS 800 2007. Pure elastic for the limit for the working stress, pure elastic approach for analysis of the structure under the working loads. And in limit state, the working loads are factored using the partial safety factor. Uh, 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 partial partial safety factor is being used in the limit state so that the working loads are factored, and the safer side the loads are being made higher by keeping it safety by using this partial safety factor. Okay, and yielding and buckling never occur at the working loads, as we can see this point in the working stress method. And also the post yielding or post buckling play important role in estimating the capacity of the structural element at the limit state. And also when we see at the working stress method, it considers only the linear elastic behavior of the materials. But when we see with the limit state method, it considered both the linear elastic as well as the non-linear linearity behavior, that is the plastic behavior of the material. And also coming to the working stress method, the serviceability and the economy are the not considered for the design. That is a major drawback or the disadvantage of the working stress method, wherein for the limit state method, serviceability and the economy are considered for the design. And also one more difference is that the heavier sections are used for working stress method, and whereas the lighter sections are being used for the limit state method. And also fatigue and fire resistance criteria is not given for the working stress method, whereas fatigue and fire resistance criteria are given for the limit state method. Okay, so these were the some of the differences which were being uh, listed out between the working stress method and the limit state method. Okay, now let's see the actions or the loads which are being experienced by the structure. Direct actions experienced by the structure due to the self weight and the external actions, and also imposed deformation such as due to the temperature and the settlement of the temperature and the settlement. Okay, IS 800 is classified various actions into the three groups: permanent actions and variable actions and the accidental actions. Okay, so these are the different these are the three classifications which are being done. Permanent action, it is due to the self weight and the fixed equipment. And variable action, it is action due to the construction and the service stage, such as that the imposed load and wind loads and the earthquake loads. And accidental load, it is due to the explosion or the impact of the vehicles, so which might occur accidentally. So And now coming to the characteristic actions, it is defined as the values of the different actions which are not expected to be exceeded with more than 5% probability during the life of the structure. Okay, so and here is a formula for the design action. It is QD is equal to sigma gamma fk into qck. Okay, where gamma fk is a partial safety factor for the different loads, k, and this can be got from the table 4 of is 800 2007, and qck is the characteristic load of the various loads. Okay, now coming to the design strength. Design strength and the few following uncertainties have to be considered while considering the design strength. Possibility of the unfavorable deviation of the material strength from the characteristic, unfavorable variation of the member size, and also unfavorable reduction in the member strength due to the fabrication and tolerances, and uncertainty in the calculation of the strength of the material. Hence, the IS 800 recommends the reduction in the strength of the materials by the partial safety factor, and the formula for the design strength is the SU divided by gamma m. Gamma m is the partial safety factor for the materials, and SU is the ultimate strength. Okay, and now let's see about the partial safety factors. As we discussed about, as we had the partial safety factor in the design strength formula also, and with the design action also. So there are basically two types of partial safety factors: one which is applied to the loads, that is gamma f, and other to the materials, gamma m. And these are the two partial safety factors which are being used. Okay, and gamma f allows for the following points: deviations of the loads from the specified values, inaccurate assessment of the loads, and the possible deviation of the actual behavior of the structure from the analysis model. Okay, and these are the following points which are being allowed by the gamma f value, and that is which is considered for the loads, and that can be got from the table 4 of is 800 2007. And now here I have listed some of the points for the gamma m, that is the partial safety factor value for the material strength. The possible reduction in the strength of the material due to the manufacturing tolerances, imperfections of the material, and uncertainty of the element behavior. Okay, so these are the some of the partial safety factors which are being used in the uh, design. So this was the basic introduction about the basic introduction about the introduction to design of steel structures. I have covered like basic points which might be helpful. Mm, which basic points like the properties of the steel, structural steel, and the stress strain curve, design philosophies, and then also the limit state design method, and the partial safety factor values which are being used. Overall, these two video lectures cover the basic idea of a basic idea about the introduction to design of steel structures. Okay, thank you for listening.